We all use AI chatbots, right? But have you ever stopped to think about a hidden safety problem that happens right before your eyes? Today, we're diving into a brand new solution that acts as a real-time safety net for AI. This is a big one, so let's get right into it.
Okay, so picture this. You've asked your favorite chatbot a question, and you see that little cursor blinking, and then the words start appearing, one by one. It feels like a real-time conversation, doesn't it? We're so used to this now.
But what if it starts typing something, well, something harmful or dangerous? Is there a way to hit the brakes and stop it right there? You'd think so, right? But with the way things are built today, the answer is a shocking no. And that, my friends, is a massive problem.
This whole real-time streaming thing, while it feels so natural, actually creates this huge critical vulnerability in our AI safety systems. And researchers, they've actually given it a name. They call it the streaming safety gap.
So you might be wondering, how does AI safety even work right now? Well, it's mostly a two-pronged approach. First, you try to train the AI itself to be helpful and harmless from the get-go. And second, you have these external systems, kind of like moderators that check the content. But here's the kicker. Both of these methods share the exact same flaw. They only check the message after it's completely finished.
Okay, so what exactly is this flaw? Why is this after-the-fact approach so broken when it comes to the AIs we use every day? Let's break it down.
Here's how it all goes wrong. Step 1, the language model starts generating something harmful. Step 2, that text is streamed directly to your screen, token by token. You're seeing it happen live. Step 3, only after the entire harmful message is finished does the moderation API kick in to check it. And step 4, the flag goes up, but it's way too late. You've already seen it. The damage is already done.
And this isn't just some minor issue. Praneeth Vadlapati, the author of the paper we're looking at today, puts it perfectly. He calls this a structural blind spot in every widely deployed LLM safety system. I mean, wow, a structural blind spot. That really tells you how big of a deal this is.
So, we've got a huge structural problem on our hands. But the good news is, there's a solution on the horizon. Let's meet the hero of our story, a kind of dedicated, real-time AI watchdog.
It's called a Large Supervisor Model, or LSM for short. Now, don't let the name intimidate you. Just think of it like a little coprocessor, a sidekick that runs right alongside the main AI. Its only job isn't to create answers, but to watch the answers being created in real time. And the second it spots something going off the rails, bam, it sends an interrupt signal to stop it in its tracks. And this slide just nails the difference. The old way is like having a smoke detector. Sure, it's useful, but it only goes off after the fire has already started spreading. It's totally reactive. The new way with these LSMs is like having a firefighter standing right there, watching for the tiniest spark. It's proactive. It stops the fire before it can even begin. And the beauty of this LSM approach is really in its design. First off, it runs in parallel, like a coprocessor, so you don't have to change or retrain the main AI at all. That's huge. It just reads the stream of words as they're being generated, and if there's a problem, it fires off what's called a structured interrupt signal to stop the generation instantly. And the best part? It does all of this with practically zero lag. It's incredibly efficient.
Okay, so a real-time watchdog sounds fantastic in theory, right? But the real question is, does it actually work in practice? Let's take a look at the data and see how it stacks up against the current systems.
And here are the numbers. On the left, we've got the new LSM. On the right, a well-known post-hoc system called LlamaGuard. And it's not even close. The LSM just blows the older tech out of the water across every single metric. But there's one number on this chart that is way more important than all the others when we're talking about safety. And that metric is called recall. In the world of safety systems, recall is king. It's pretty simple. It measures what percentage of the actually harmful stuff the system manages to catch. Think about it. If your recall score is low, it means bad stuff is slipping through the cracks. A high recall score means your safety net is actually working.
So what was the LSM's recall score? A whopping 93.27%. Let's put that in perspective. That means it successfully identified and caught over 93 out of every 100 pieces of harmful content it was tested on. That is a massive improvement.
I mean, just look at this comparison. The LSM is catching over 93% of the harmful stuff. The post-hoc system, just over 84%. That 9-point difference might not sound like a lot, but in the world of safety, that gap is the difference between a system you can trust and a system that's leaving you vulnerable.
So what does this all mean for the future of AI? Well, it's not just a small tweak. This really represents a fundamental shift in how we should be thinking about AI safety.
The real game changer here, the key innovation, is all about closing that time gap. The gap between when something is created and when it's checked. We're finally moving away from analyzing the past, and instead, we're supervising the present in real time. Now, of course, it's not perfect, yet. This is still an evolving technology. For example, the training data used for this paper covered 4 major harm categories, but not all of them. There's also a false positive rate of about 12%, which means it sometimes flags things that are okay, and it doesn't yet look at the user's prompt for the full context. But honestly, these aren't dead ends. There's super exciting areas for future research to make this even better.
It really leaves you with a powerful question, doesn't it? As we push to make our AIs more and more instantaneous, shouldn't their safety nets be instantaneous too? With LSMs, it looks like we finally have the technology to make that a reality.